So section 4 continues with some additional information. Earlier we talked about naming triangles as specifically as possible, which hinged on their side length. If we had actual coordinates, that would be a matter of applying the distance formula 3 times to determine if you had 1, 2, or 3 equal sides, to name it as scalene, isosceles, or equilateral. But what's more interesting is what if we are talking about a generic triangle with variables as our coordinates. And so the same rule applies, that we are going to calculate our distance 3 times. So we are going to do the distance of AB, and that's going to be equal to A minus 0 squared plus B minus 0 squared, which is going to end up being the square root of A squared plus B squared. Remember order of operations, that square root implies parentheses, and so you can't ever take the square root across an addition or subtraction problem. Then we're going to work our way around and we are going to calculate the distance of B to C. And so we have the distance of 2A minus A, the quantity squared, plus B minus B, the quantity squared. Oops, this is supposed to be 0. B minus 0, the quantity squared. And that is equal to the square root of A squared plus B squared. So now we know we have at least 2 equal sides because these two distances are the same. So then we're going to calculate this last distance, which is the distance of A to C. And so if we do 2A minus 0, the quantity squared, plus 0 minus 0, the quantity squared, we get the square root of 4A squared, which can be simplified as 2A. So from this, our conclusion then, therefore, triangle ABC is isosceles, because our work here, here, and here proves 2 equal sides. If you additionally want to go on to say there are 2 equal sides because 2 equal sides, that's even better. You're welcome to do that, because we could say that AB equals BC, or 2 equal sides, and that forms a really solid explanation. Now, not every set of triangles, every set of sides will form a triangle. So, and then there are relationships between angles and sides. So basically, these 2 points boil down to this: little side, little angle, big side, big angle. Opposite the biggest angle is going to be the biggest side. Opposite the littlest side is going to be the littlest angle. And that should just make really good common sense. So what this allows us to do is order lengths of sides and order angles. And usually we're going to go least to greatest. So what I like to do in this problem, you see that we only have 2 angles. So I have to take 180 minus 65 minus 30 to find that third angle, minus 95. And so angle A is 85 degrees. And so I think it's very simple to come in and say littlest one. So here's my littlest one. So this is 1, 65, this is 2, 85, this is 3. And so I have that AC is less than AB is less than BC. And I just order them least to greatest. Same thing is going to work for the angles. Here's my smallest side, so that means that's my smallest angle. Second and third. So when I go to write it, I have angle C is less than angle B is less than angle A. So a very straightforward application of that. As an extension of this, there's rules about what lengths of sides will actually form a triangle. And those are summarized by these 3 rules, which basically says the sum of any 2 sides must be greater than the third side. If any one of these 3 rules, inequalities, fails, no triangle. So all 3 true, you can make a triangle. Any one false, no triangle. So as soon as you get to a false one, you can stop. So can 2, 3, and 5 be the lengths of a triangle? I like to draw pictures because it just visually helps me. And I start through. Is 2 plus 5 greater than 3? True. Is 5 plus 3 greater than 2? True. Is 2 plus 3 greater than 5? That is false. It's not greater, it's equal. Therefore, not a triangle. No matter how you work it, 2, 3, and 5 will not form a triangle. Exact same process with 5, 7, and 9. 5 plus 7 is greater than 9. True. 7 plus 9 is greater than 5. True. And 5 plus 9 is greater than 7. True. Therefore, it makes a triangle. Now, this formula can also be applied to finding out the range of values. Now, this would have real-life application if you were building a flower bed or you were building a rafter or a triangular piece of deck, and you would want to know what is the range, how big or how small could you make your triangle, because again, there's rules of what would actually form a triangle. So we're going to set up our 3 inequalities and we're going to solve each one. So let's get these set up first. So 4 plus s has to be greater than 7. 7 plus s has to be greater than 4, and 7 plus 4 has to be greater than s. I'm going to solve each one. So if I subtract 4, I have s is greater than 3. Here, if I subtract 7, I'm going to have s is greater than negative 3. And here I'm going to have 11 is greater than s. Well, s greater than negative 3 doesn't apply because we can't have negative values. Here's my bottom value, and here's my top value for the max and the min that my triangle sides could be. So the cleanest way to write this is as a compound inequality. Start with your littlest one. If you think about pancake flipping this over, you would have 3 is less than s is less than 11. Basically, s has to be between 3.1 and 10.99, because remember, it can't be those values because we just have the less than amounts. So you could build a triangular fence, a triangle garden, a deck with sides 4 and 7. Let's say those were against your house, questioning how big or how small that last opening here could be, and it could be between 3.1 feet and 10.99. Good luck with your homework.